So we have step response. How about the impulse response? Of course, that means the input will be strength A times delta T. If you remember earlier for first order systems, impulse response can be found by take derivative of the step response. So you can do exactly the same things. Okay, so you know the step response for three different cases. Okay, so the impulse response take derivative of these three. Okay, so would be derivative of step response. Okay, again, you can do that mathematically, and let's just look at the impulse response curve. So similar to the first order system. So impulse response. So you should have oscillation and decay. Or you might have impulse and decay. But again, if you have oscillation, meaning that's underdamped. Underdamped for oscillations. Okay. So in this formula sheet, I also give you the last one, free response. In other words, free response of a second order system. Again, if the governing equations, the differential equation is in this form, okay, free response meaning there's no input. This term goes to 0, but you do have initial values. Since it's second order system, so you should have 2 x naught, sorry, x dot, the 2 of initial values. Or sometimes we say this is velocity naught. Okay, again, same things, overdamp. If you look at the solution form right here, it's 2 exponential function with the coefficients. It's an exponential function, no sine or cosine, so there's no oscillation. Critically damped, again, exponential function, another exponential functions, combined, there's no oscillation. Under damped, you do have oscillations. Okay, you have these sine terms and cosine term right here. Okay, so this formula sheet has been posted on Blackboard, so you can download it for your reference.